In this video, we're going to talk about heat of fusion, heat of vaporization. Now, in New York State, we have the reference tables. Table B is where you're going to see those two values for heat of fusion, heat of vaporization. And so heat of fusion, 334 joules per gram. Hopefully that will show up. Heat of vaporization, that second one down, 2260 joules per gram. And so we'll write those up here as well. 334 joules per gram, 2260 joules per gram. And that's for water. Okay, that only applies to water. It will be different for different substances. Just like the specific heat capacity, which is also on table B. Again, these are table B values. Sorry. Brain's not working is what I want to write. So table B, I said the word value and I wrote the letter B. But where we also see these are on table T, with our formulas for heat of fusion, calculating that and calculating heat of vaporization. So Q equals MHF and Q equals MHV. Q, of course, is going to be our energy, and M is mass. HV and HF hopefully makes sense. And so this is what we want to figure out, the amount of energy to either melt stuff or to freeze stuff. And so our HF is melting and freezing. And HV would be boiling and condensing. So just think about it. These things happen at opposite reactions or opposite rates, whether I'm adding energy or if I'm removing energy. So if I want to melt ice, I got to add 334 joules of energy into that block of ice, into that gram of ice specifically. If I want to boil that same gram, it's going to be an additional 2260 joules. Now, if I freeze that liquid, instead of it gaining, now it's going to lose that energy. It has to lose the amount of energy that it gained. It's basically equal and opposite. And so you may see a question on the Regents that asks, how much energy is required to, take a 10 gram block of ice at its freezing point and melt it. So, for example, a 10 gram block of ice and melt it. So we're going to be using this formula, Q equals MHF. So Q, we want to know, for example, again, how much energy to take a 10 gram block of ice and to melt it. So Q is equal to 10 grams times 334 joules per gram. My grams will cancel out, and I'm left with 3,340. We're just going to do and stick with some simple math. We're just moving the decimal over one spot. The same thing would hold true. How much energy would now be required to boil that same amount? We're still going to use the same amount. If I have 10 grams of ice and I melt it, I now have 10 grams of water. Okay, law of conservation of matter, right? I have 10 grams and 10 grams. So I would just be multiplying that instead. If I wanted to vaporize it or to boil it, it would be Q equals 10 grams times 2260 joules per gram. Again, grams cancel. We get 22,600 joules. And these are both going to be positive values. Now, sometimes you hear questions that say the energy was released. So it might say, how big was the block of ice? So let's say, for example, I'm just going to erase my formulas. And again, we'll try to stick with simple math. It says, let's see, 6,000 off the top of my head, 6,680 joules were added to melt a block of ice. How big was the block? Okay, now we're just solving for a different piece here. So again, we're using the same formula. Q equals MHF. Notice again, there's no temperatures listed here, so I'm not going to be using Q equals MC delta T. I only use Q equals MC delta T if we talk about change in temperature. There is no change in temperature in melting. There's no change in temperature in boiling. So my Q, 6,680 joules, I'm trying to solve for M, and I know my HF is 334 joules per gram. So I want to get mass by itself. I need to divide both sides by 334 joules per gram. Divide by 334 joules per gram. My joules are going to cancel out. And basically, I just took something that was half, but of course we also multiplied it by another value there. My mass is going to be 20 grams. And so we can easily solve for the mass, we can solve for the energy, or we can solve for the heat of fusion for an unknown. Maybe you're given the mass and you're given the energy and you're solving for the heat of fusion of copper. Okay, how much energy does it take to melt a chunk of copper or a chunk of lead or a chunk of steel or iron? Okay, all materials will have their own specific heats. Now, the only one that's really listed, of course, is water, and water, of course, is not an element by itself, but it's actually a molecule. And so all materials will have a different property. Just like they have different densities, they will have a different heat of fusion. They'll also have a different heat of vaporization. So hopefully you found some benefit from this video on heat of fusion, heat of vaporization. If you have any questions, comments, you can leave them below, and I look forward to seeing your success in chemistry in the future.